Hello everyone, welcome to our channel Cable Couples. In today's video we will learn what is optical fiber and on what principle it is based.
And why we have upgraded our old copper cabling to fiber cabling and how it is manufactured.
And who are the fiber manufacturers in India and worldwide.
So guys, this is optical fiber cable and inside these are optical fibers, which is actually the heart of the cable. So I just took out one fiber from this cable. You can see this is very flexible thin strand which is made up of ultra pure silica, and you can compare the diameter of this fiber with human hair.
Optical fiber is basically a technology associated with the data transmission using light pulses traveling from one end of the fiber to another end of the fiber.
It is comprised of two basic elements made of glass, the core and the cladding. The core, the center part of the fiber, is the area through which the light signals are transmitted. The cladding layer completely surrounds the core, keeping the light from escaping. So optical fiber is based on total internal reflection principle. Light waves has three primary properties that affect total internal reflection. These are reflection, refraction, and refractive index. We see a light wave as it propagates straight through two different mediums. The speed of the light wave changes depending on medium through which it passes. Medium A and medium B each have a different refractive index designated by a lowercase n. Medium B with a slower moving light wave has a higher refractive index than medium A. For example, water has a higher refractive index than air. A wave propagating through water will travel at a slower speed than the same wave in the air. The boundary or interface between two medium is where the refraction and reflection occurs. Refraction is the bending of the light wave as it passes through one medium to the next. If the second medium prevents light from passing through the interface, reflection occurs. Two factors must be considered when determining the degree of refraction or reflection: the angle at which the light wave strikes the interface and the reflection index of one medium is relation to the other. Snell's law is used to determine the amount of refraction that will occur between two medium. Imagine a light perpendicular to the interface. This line is referred to as the normal. A light wave traveling straight into the new medium or along the normal will change speed but not change direction. However, when the light hits the interface at an angle, the change in light speed will cause the beam to change direction slightly and propagate through the second medium at different angle. The angle at which the light hits the interface is referred to as the angle of incidence. The angle at which the light propagates to the new medium is called the angle of refraction. By placing the known values into Snell's formula, the degree of refraction can be determined. Snell's law states that if the refractive index of the second medium is greater than that of the first, the angle of refraction is smaller than the angle of incidence, and vice versa. If the refraction index of the second medium is smaller than that of the first, the angle of refraction is greater than that of the angle of incidence. This is the principle that enables light to travel through a fiber optic strand. The core has a higher refractive index than the surrounding cladding. A light wave from the core will increase in speed when it enters the cladding, which has a slower refractive index. Notice that as the angle of incidence becomes greater than the angle of refraction approaches the boundary or interface, if the angle of incidence is such that the refracted light wave travels through the boundary between the core and the cladding, it is known as the critical angle. It is the striking angle or the angle of incidence is greater than the critical angle. The light will be refracted into no refraction, which is what known as total internal reflection.